Hi, this is Mrs. Kidman, and welcome back for the next part of our absolute value function lesson. In this lesson, we will be discussing how the value of a affects the function. So again, a is the number that we're multiplying times the absolute value. So we want to look at how does changing this value of a affect what the function looks like. Now, as a quick review, let's talk about what happens with k and h and how they affect the function. So when k is positive, so k is that one that we add outside the absolute value, what that does is it is going to shift the expression up. And an example of when we might see that would be something like f of x equals the absolute value of x plus 2. That would shift our absolute value function up 2 units. K is negative. When k is negative, what's going to happen is it's actually going to shift our graph down. And that shift down is going to move it in the other direction. So an example of what that one might look like is when f of x equals the absolute value of x minus 4. So instead of going up 2, this is going to shift it down 4. Now that's what k does, is it shifts it up and down. That's how it affects it. How h affects it is it shifts it left and right. So when h is positive, we are going to shift to the right. And an example of when h is positive is when we have a function that looks like this, the absolute value of x minus 3. Now remember, in our function here with the variables, we have the absolute value of x minus h. So h, in order for it to be positive, we have to have a minus a positive number. So in this case, we have x minus a positive 3. And that's when it's going to shift it to the right. When h is negative, then we are going to shift to the left. And when h is negative, what our function is going to look like is it's going to have something like f of x equals the absolute value of x plus 4. And remember, that shows that h is negative because really what we're saying is the absolute value of x minus negative 4. But remember, in math, we don't like a minus and negative, so we don't use it. Now, let's talk about a and see what happens. We are going to be looking at how these compare to our parent function. So let's open up Desmos and take a look. So here we are in Desmos. Remember that that red function there is going to be our parent function, or the absolute value of x. Now let's see what happens when we take that absolute value of x and multiply it by 2. And let's not use the same color there. Let's see if it'll give us a new one. Q of x equals 2 times the absolute value of x. Okay, so our new function here is blue compared to our parent function, which is red. The parent function, notice, spreads out more than the original function. So this 2, it thins in. The big thing that we can look at is as we zoom in on our function here, we can see that at 1, the parent function intersects at 1. However, the new function, or that 2 times the absolute value of x, is going to be at 1, 2. So notice instead of it being 1, 1, it's now 1, 2. So we've multiplied it by a factor of 2. And what that's done is it's actually made the function get thinner. Now think of it like if you had a rubber band. If you were to stretch out a rubber band, that rubber band will get thinner and thinner, right? That's the same thing that we're doing with this function. We're stretching our function. So instead of it going from 1 to 1, it's going from 1 to 2. So we're stretching it up and it's causing our function to get thinner. Now let's see what happens if we put in that other function. So let's look at p of x equals, let's start with 1/2 times the absolute value of x. What does that do? Notice that function there is our green function. And you can see that at the value 1, along that function, we are actually only sitting right at half. So it's actually made the function wider. Now think of it with your rubber band again. Say you're holding it, and you push the top of that rubber band down towards the bottom. Notice how it gets wider. We're shrinking what that number, what y value goes with the x value. And as we shrink that y value, our function has to get wider because we still have to put the function somewhere. So that's what happens there. The reason I use that rubber band example is because the words that we use to describe what happens when we do 2 times that function, when it stretches out, is called a vertical stretch because we're stretching it in the vertical direction. Similarly, like we see with this green function, when we stretch that one, we're not stretching it up, we're actually shrinking it. We're changing, we're reducing what value goes with 1. Instead of it being 1, 1, we're now at 1.5, and the function gets wider. So we actually call that one a vertical shrink because we're shrinking the y value associated with the x value. Now, this green one was not the function that we said we were going to look at. We were going to look at -1/2. So let's see what happens when we change this from a 1/2 to a -1/2. Whoa, did you guys see that? It went from facing up to facing down. So that negative on the A is actually going to reflect it across our x-axis. So it's going to change the direction that it is. So that's what we want to look at here with our graph, with our A, how it changes it. Well, we just saw on the Desmos graph that when it was this 2 and the number was bigger than 1, so this is bigger than 1, what happened was it had a vertical stretch, is the words that we call it. And the function, it had a vertical stretch, and we call it by a factor of 2. So what that means is that the function got thinner 2 times. So it got not thinner 2 times. The best way to phrase that is probably 2 times thinner. So we now have a 2 times thinner function that we're looking at here because we multiplied it by 2. Now this other function kind of has 2 parts to it. Part number 1 is when we have one that is less than 1, okay, but bigger than 0 because it's a fraction, right? So it's less than 1, bigger than 0, that we end up with a vertical shrink. And what that means is, again, that the y value associated with our x goes down. And this vertical shrink was by a factor of 2. The reason why it's by a factor of 2 is because the denominator of our fraction here is 2. So we're still affecting it by a factor of 2, but this time we're shrinking it 1/2 instead of stretching it 1/2. So you could also say a factor of 1/2, right? Because we're shrinking it that way. The second component to this example here of A is this negative sign. When A is negative, we saw what happened, right? We can look at it again. When it's negative, it opens down. When it's positive, it opens up. By changing it to a negative, we reflected it across the x-axis. So with it being negative, notice it opens down and it's reflected across that x-axis. So let's kind of use that table that we have here to explain what happens with A. So when A is positive, so that's what we're talking about. We're just looking at either A versus negative A, right? Sometimes our A is a negative value. So when A equals a positive number, it's going to open up. And when it opens up, that means it's going to stay the direction of the absolute value of x, right? It's going to stay open that same way. So an example of when we might see this is like that one we saw on the previous page. F of x equals 2 times the absolute value of x. That's a great example. When A is negative, on the other hand, as we saw, it's going to open down. And the way that we describe what happens there, so describing that shift, is we say it reflects across the x-axis. So quick reminder, this right here is the x-axis. That's the horizontal one, and it flipped across it. So that's why we say it reflects across it. So an example of when we might have a negative A would be f of x equals -2 times the absolute value of x. Okay, so that's what happens when A is negative. Now, what happens if the absolute value of a is greater than 1? The reason why we want to talk about the absolute value of a is because that positive and negative part of it just tell us which way it faces. So we really just care about what that number, the a is, what the whole number is. So if a is 4, 4 is greater than 1. If a is negative 4, if we get rid of that negative, or if we find the absolute value of negative 4, it's 4, and that's still greater than 1. So notice when we found the absolute value, when we looked at the function that was the absolute value of 2 times the absolute value of x, notice that it had a vertical stretch. That's the way that we describe it. So it's a vertical stretch. And it's by a factor of a, is how we describe what happens there. So it's going to get vertically stretched. And vertically stretched means it's going to get thin, right? So we're going to shrink or get thinner, or we're going to not shrink, we're going to stretch it, and our function's going to get thinner. So an example that looks like this would be f of x equals 4 times the absolute value of x, right? Because 4 is the absolute value of 4 is greater than 1. Now what happens if the absolute value of a is between 0 and 1? So think of that example that we had up here, negative 1/2. What's the absolute value of negative 1/2? That's going to be 1/2. So 1/2 is between 0 and 1. And when we looked at that problem, what we ended up dealing with was we had something called a vertical shrink. Okay, and we would write or describe that shift that it was a vertical shrink by a factor of a. And when we do a vertical shrink, what that means is that our y value that's associated with the x goes down compared to our parent function. So this actually causes our function to get wider. Okay, and an example of when the absolute value of a is between 0 and 1 would be something like f of x equals 1/3 times the absolute value of x. So again, if a is positive, it's going to open up. If a is negative, it opens down. If a is negative, we say it reflects across the x-axis. That's the description of that shift. If a is bigger than 1, either positive or negative, it's a bigger number than 1, then it's going to have a vertical stretch, or the function's going to thin, but it's going to stretch it out. So the value that's associated with our x is going to be a higher number. When a is a fraction between 0 and 1, positive or negative, it's going to have a vertical shrink. And so our function's going to get wider because the value associated with x equals 1 is going to reduce. Okay, so all of those values are going to reduce. And that's how a affects our function. It tells us which direction it's going to open and how thin or wide it's going to be.